So today I'm going to solve question number 13.14. This problem is of Nucleus chapter, grade 12 physics, NCERT textbook. So here we are given that a neon is emitting beta minus particle, that is due to the neutron that is present in the nucleus of the neon converts itself into a proton and electron. So an electron is ejected out, which is called beta minus, and we are supposed to write down the Q value and the kinetic energy of the electron which is emitted. So first of all, let us try to understand what is happening over here. So here guys, we have a neon. This neon has atomic number 10, mass number 23. Now it releases an electron because a neutron gets converted into proton and electron, and the electron is ejected out. And in this process, always remember, in alpha and beta processes, law of conservation of mass energy, law of conservation of momentum, law of conservation of charge, and law of conservation of nuclear numbers. These all laws are followed. So atomic number and mass number should be conserved. So here atomic number is 10. So here it should be 11, because 11 plus minus 1 is 10, and 23, which is 0 plus again 23. So we know that 11 is sodium, so we get sodium. Now this is a spontaneous process, people. And in spontaneous process, from reactant to product, we know that mass decreases. So the Q value is the energy which is positive and it is released. So basically Q value is written like this. Q value is the mass of reactant minus the mass of product. So mass in the product side you have masses of electron and the masses of sodium times C square. But guys, there is a small error in the question. This is 22.98770 atomic mass unit, and these two are the atomic masses. Always remember, the masses which are given to us are atomic masses, and we need to remove the masses of electrons. So if I directly substitute these values in this equation, I am going to get a wrong answer. So ideally, I will explain you in depth why I am doing that. First of all, I am writing the correct one. Since this is an atomic mass, so mass of neon atom, and in neon atom there are 10 electrons. So 10 times the mass of electron. If I remove that, I get the masses of nuclei, because in Q value we only consider the masses of nuclei, minus the mass of electron. There are 11 electrons in sodium times C square. This is our correct equation. Now I would like to make a note that in beta plus, beta minus, and electron capture, you will have to remove the masses of electron. So remove the masses of electrons. But in alpha decay, when a neutron is being emitted, even if you do not remove the masses of electrons, you will be getting the correct answer. Now why it is so, let us try to understand. See, if you do not remove the electron's mass, and if you ideally go by, say this is equation number 1, if you solve your question by directly substituting the atomic mass, then the problem would not be justified. Because on one side, on the product side, you have an electron and its mass you are considering over here. And from the atomic masses, you are not removing the masses of the electrons. So on one side, you are considering the mass of electron, and on the other side, from the atoms, you are not removing the masses of electrons. So this problem will not be justified. Yes, if you are dealing with heavy nuclei like alpha decay, neutrons, these are all massive particles. And if you are neglecting the masses of electrons, you will still get the correct answer. So that is why in CBSE textbooks, in these three processes, we remove the masses of electrons, and in rest of the other processes, we do not remove the mass of electron. So if I open up this bracket, I get mass of neon minus the mass of minus the mass of 11 electrons, so multiplied by 11, and if I open up the bracket, minus the mass of sodium, again plus 11 times the mass of electron times c square. As we can see that anyhow they are going to get cancelled, so the Q value, now if I substitute these masses over here, correct, then I am going to get my answer as 0.0046 89 times c square. Now we know that 1 AMU is equal to, these are atomic mass unit, 1 AMU is equal to 931. We know that 1 AMU is equal to 931.5 MeV. So this much mass, so 931.5 MeV. So the Q value that I am going to get is 4.37 MeV. Now guys, the problem is what happens to this energy. So let us try to understand this. Suppose you have this neon atom at rest. So that means its momentum is going to be 0. Now this neon atom splits up into two parts. One is beta minus and the another is the sodium. And the sodium and beta minus would be traveling in the opposite direction because the initial momentum was 0. So the final momentum must be also 0. So that means the momentum of sodium must be equal to the momentum of beta minus. And both these momentums are equal and opposite in direction. But we know that kinetic energy is equal to P square upon 2m. Now the mass of the beta particle is extremely less, so its kinetic energy is going to be very large. And since the mass of the sodium nuclei is very large, its kinetic energy is going to be very, very small. So kinetic energy of beta minus is going to be very, very larger than the kinetic energy of the sodium nuclei. So where do they receive their kinetic energy from? The answer is Q value. So this Q value, which is the energy released due to the decrease in mass, is itself going to be divided between these two, but not 50-50. Almost all energy is going to be received by the beta particle and very negligible energy is going to get received by the sodium nuclei. So we can say that the Q value itself is the almost complete energy that is going to be received by the beta particle, and almost zero energy will go into the account of sodium nuclei, which is the answer to our problem.